Welcome to your favorite intermediate algebra class. We'll take a look today at geometric sequences and series. First of all, what a geometric sequence is it's any sort of sequence in which the ratio of any term to the previous term is constant. So if you're looking at this first one's actually geometric, 1, 6, 36. And can you see how as you go to get from 1 to 6, you're multiplying by 6, and then you take the 6, you multiply by 6, take the 36 times 6 to get 216, take 216, multiply it by 6, and so on. So more formally, you have a what's called common ratio. So if you call this A1, A2, A3, A4, A5, and so on, your second term divided by your first term, that will give you your common ratio. Now it has to be fixed, right? You have to have a fixed common ratio throughout. So if you take the third term over the second term, 36 over 6, you still get 6. Whoops, that's supposed to be 6 up there. Okay. Then you take the 216 over the 36, 6, right? And then you take the 1296, the fifth term over the fourth term. You get 6. So you say, yes, this is definitely geometric because we have a common fixed ratio here. Okay. So the next one, 625, 125, 25, 5, 1. Is this thing geometric? Well, again, to figure out if it is geometric, say, well, is there a common ratio? You multiply 625 by what to get 125? You take 125 times what to get 25, all right? And if you're not sure, just take the second term, divide by the first term. So 125 over 625. Both those go into 125, so it's a fifth. That should be the exact same thing as the third over the second. So 25 over 125, both those go into 25, you get 1/5. So far, so good. You take the fourth term over the third term, and so on. 5 over 25, you get a fifth. And finally, the fifth term over the fourth term, you're like, oh yeah, look at that. All of them give you, 1/5 here, 1/5. So our common ratio is 1/5. It is geometric again because the sequence in which the ratio of any term to the previous term is constant. Okay, let's look at another one here. How about this one? Let's see, -1 over 1, -1. Let's take the third one over the second one. Like, oh, no, it is not. Those are not equal. This is not geometric. Okay, so geometric, again, should have a fixed common ratio, okay, between terms here. Now, if you have a geometric sequence, okay, last time we learned about arithmetic sequences and I gave you a rule. Well, this time we're learning about geometric sequences, okay, so we have that common ratio, right? We're multiplying by a certain amount to get to the next term there. And if you do have a geometric sequence, you have a given formula, so you can figure it out. The rule, the nth term formula from the formula, a sub n equals a1, the first term, times the common ratio to the n minus 1. So let's take a look at this first one. So we've got this geometric sequence here, 5, 10, 20, 40, and so on. So what's our common ratio? Number one, we're going to say, let's find r. So we say, oh, well, do you notice that r is you're going to take the second term over the first term, right? So 10 over 5, you see how your common ratio is 2. That's the same thing as 20 over 10, still 2, or 40 over 20, right? So your common ratio is 2. Number 2, we know our first term already is 5. Okay, those are the two things we need. We need our common ratio r is 2, we need the first term is 5. Now that we know that, okay, we plug them into the formula. So an is a1r to the n minus 1. So the nth term is 5. There's our a1. Our common ratio is 2 to the n minus 1. Okay, there's our nth term formula. So for instance, if we were to figure out our fifth term, right? Our fourth term, you see how our fourth term is 40, right? So the next term would obviously be, you know how you're multiplying by 2 each time? You're multiplying by that common ratio. So we know intuitively 40 times 2, it's going to be 80, right? Because you're multiplying 40 times 2. Well, let's check it. The fifth term should be 5 times 2 to the n. Our n is 5 minus 1. So we got 5 and 2 to the fourth. So the fifth term, let me take it up here. The fifth term is 5. Now 2 to the fourth is 16. Right? 2 times 2 times 2 times 2. And 16 times 5, 80. Look at that. There's our fifth term. Our fifth term really is 80. Okay? Let's go down to this one here. Write a rule for this geometric sequence, and then we're actually going to find the 11th term. Okay? Oh, you know what I should have said up here? It did ask us to find the 25th term, actually. So let's go ahead and let's use our formula here and find the 25th term. I forgot to finish this off here. Okay, so the 25th term, 5 times 2 to the 25 minus 1. So I'm going to punch in 2 to the 24th into my calculator. So 2 to the 24th is 16777,216, and I multiply by that 5. Okay, then multiply by 5 times 5 equals big number 83886080. 83886080 is, I believe, what I said there. So there's our 25th term. That's a really large number there. Okay, sorry about that. Back to the green example here. Write a rule, okay, for this geometric sequence. So again, this first thing that we're going to do here is we're going to find our common ratio. So number 1, find R. So our R is 108 over 81, okay? Or same thing as 144 over 108, right? And same thing as 192 over 144. Anyway, so on. Well, I'm going to take this 108. I know both of those go into 9. So that is 9. 108 and 9 is 12. Both those go into 3. So it's 4/3. Okay, each of these is 4/3. So we have our common ratio of 4/3. Definitely geometric, okay? Number 2. So after we know that R is 4/3, I say I know my first term. That's nice. They give it to me. It's 81. So number 3, now we just write the formula, R to the n minus 1. Okay, A subscript n is first term 81. R is 4/3 to the n minus 1. Okay, there's our formula for this. And then this is asking us to find A subscript 11. So the 11th term here. Find the 11th term. So 81, 4/3 to the 11 minus 1. 81, that's 4/3 to the 10. So that's 81, and that's 4 to the 10th over 3 to the 10th. Okay, so that's 4 to the 10th. Okay, that's a big number. I'm just going to spit out the approximation here. I'm going to go 4/3, and I'm going to take that 1.3 repeated. I'm going to take that to the 10th, and then I'm going to multiply by 81 in front. Times 81, 1438.38, approximately 1438.38. I'm just again, I approximated that. That's actually, I think I have the exact answer here if you do want to write it in exact form here. 1048,576, all divided by 729. There it is in exact. Okay, so there's your 11th term. Here we got the second term is 6. The common ratio R equals 3. So let's kind of make this visual for just a minute here. Kind of write out a couple terms here. Now we know the second term is 6, right? Now, since the common ratio is 3, so this is multiplying by 3 each time. So 6 times 3, 18. 18 times 3, 54, and so on, right? So what would the first term have to be? So what times 3, whoops, what times 3, do that, oh gosh. What times 3 gives you 6? You say, oh, 2. So the first term is 2. Now, just in case they don't give you just the second term and it's that easy to go back to the first, to find your A1, you can always use the formula, okay? So what I mean by that is in case, like instead of the second term being 6, right, A2 equals 6, let's say they give you the 200th term, right, and you don't want to just go back, if you will, to the first term there. Okay, so you just plug it in. So we find A1 knowing that A2 is 6. Okay, so we plug in A2. So say A2. So my N is 2. I don't know my first term. I know my R. We also knew my R was 3, right? 3. N is 2 again, right? Because it's the second term. Okay, and what was A2? A2 was 6. So I fill it in on that second line. And we got 3 to the 1, right? So 6 equals 3 times A subscript 1. Divide both sides by 3. So 2 is our first term. Okay, now we go over here and we say, oh, we know R is 3. We know our first term is 2. We also verified that again. And now we can write the formula. AN is A1, R to the N minus 1 for a geometric sequence. R is 3. There's our nth term formula. And from that, we can do whatever we need to do, right? We can find any term that we want, okay? Now, similar to when we did this with arithmetic sequences, let's say you're given 2 terms. You have no common ratio. How are you going to figure this out? Say, well, let me just use the 2 terms that I'm given. So I say, well, I know A2 is -8, and I'm going to write the formula for that and see what I have. And then I'm going to use the fact that the 7th term is -256. I'm going to fill in whatever I have on the formula for that. Okay, and I'm going to solve that down, and let's see where we get to here. So the second term, so n is 2 here. First term we don't know. R we don't know. But again, n is 2, so fill that in. And what is A2? What is A2? It's -8, right? R to the 2 minus 1, it's just R to the 1, okay? So here we have -8 equals the first term times the common ratio, okay? Over here, let's do it now. The 7th term, so n is 7. Okay, 7th term is what? -256, okay? Now, so you have -8 equals A1R, -256 equals A1R to the 6, okay? 2 unknowns, A1, first term, and R, and 2 equations. So this is very solvable, and what we do is we solve that by substitution. At least that's one of the ways that we can do that, okay? So why don't we substitute for, how about A1? Let's solve this for A1. So let's divide this by R, divide that by R. So the first term is -8 over R. Okay, so we're going to plug that in for A1. So make a little substitution right there. -8 over R. Okay, that's our substitution. All this other stuff stays the same. That's R to the 6th. Put the R to the 6th over 1 there. So we got -8 R to the 6th all over R. So one of these R's is going to cancel again and leave us with R to the 5th. So we got -8 R to the 5th equals -256. So -256 over 8 gives you 32. So R to the 5th equals 32. So we solve that for r. So we got to take that fifth root. So to the 1/5 power, whoops, 1/5 power. So r equals 32 to the 1/5. Another way to write that is the fifth root of 32. So r equals 32 to the 1/5, same thing as the fifth root of 32. I say, oh, I need 5 of a kind, right? Well, isn't 32 8 times 4? And isn't 8 2 times 2 times 2? There's 8. There's 4, right? 8 times 4 is 32. Perfect, I got 5 of a kind. The fifth root of 32 is 2. Okay, so now that we know, okay, that was our solving by substitution. So now we know r is 2. So I'm going to go back to that a1 being negative 8 over r. I'm going to use that part where I substituted, and I can find my first term, negative 8 over 2. So my first term has got to be negative 4. Okay, let me go down a little further here. Now we know r is 2, first term's negative 4, and I can write my formula. So my first term, negative 4, my r2 to the n minus 1. There it is. Negative 4 times 2 to the n minus 1. Okay? So that's how you're going to solve that if you have two given terms, right? You have no common ratio, you have no first term. Okay, you go ahead and you make the substitution. All right, that brings us to finding a sum of a geometric series, okay? So again, we're working with geometric series all during this section. So you can find the sum of n terms, and here's your formula for it. The sum of the first n terms of a geometric series with a common ratio that is r not being equal to 1 is the following. There's your formula, okay? So we have two parts to this first one. First of all, let's find part A, the sum of the first 10 terms. Okay, let's do that. Part A. Let's write this formula, A1, 1 minus r to the n over 1 minus r. Okay, this is for a sum of a geometric series. So part A, sum of the first 10 terms. So I say, well, what is the very first term, okay, for this geometric series? And I didn't even give you the series. Here's the series. This is negative 1 plus negative 3 plus negative 9 plus negative 27 plus, okay, there it is. So there's your first term, second term, third term, and so on, okay? All right, so our first term is negative 1. 1 minus, now we got to figure out our common ratio. So go to the side and say, well, r is second term over first term, right? So 3, or you could have taken a third over the second. Either way, your common ratio is 3. So 1 minus 3 to the n power. Now our n is 10, right? N is 10 because we're finding the sum of the first 10 terms. Over 1 minus, again, our common ratio is 3. Okay, so we got negative 1, 1 minus 3 to the 10th, I don't know. Got to punch that in here. 59049 over negative 2, 1 minus 3. Okay, keep going on this. Negative 1, that's negative 59048 over negative 2. 59048 over 2, negative over negative is positive. So we got 29524 times negative 1, negative 29524. That is the sum of the first 10 terms there, okay? 29524. I'm sorry, negative 29, comma, 524 there, okay? Now, part B. Part B, let me erase this for a minute. Part B. Find n such that Sn is negative 797,161. Okay, so I go ahead and write my formula here. Let's see what we got if I fill this in. We want to find the sum of how many terms? Well, I know the sum of however many terms is negative 797,161. Okay, I know our first term is negative 1. I know our common ratio was 3, so 1 minus 3 to the n over 1 minus 3. Okay, and now we're just going to go to town on this and see if we can figure out the algebra. Okay, so we got negative 1, we got 1 minus 3 to the n over negative 2. Okay, negative 1 over negative 2, that just leaves us with a negative over negative positive 1 minus 3 to the n all over 2. Okay, multiply both sides by 2. Okay, multiply both sides. So I'm going like this. Times 2, negative 797,161 times 2. Punch that in. 1594322. Is that what I said? Negative 1594322. Okay, subtract 1 from both sides. Negative 1594323. So I subtracted 1. Negative 3 to the n. Let's divide this by that negative 1 there. So I got 1594323 equals 3 to the n. You know what? Let me write it this way. 3 to the n is 1. Room here. 1594323. Okay, what's the inverse of 3 to the n? So if you remember back, it's been a long time. The inverse of 3 to the x is log base 3 of x, okay? And that's how you're going to undo this, if you will. You're going to run the inverse. You're going to run log base 3 on this side, log base 3 here. Because log base 3 of 3 to the n is just n. Okay? Because the composition f of g of x, if f and g are inverses, is x. Okay? So now we got to just punch this in. Log base 3 of 1594323. So you punch that into your TI-89. Or if you don't have that, you got to change your base. If you only have a calculator that does log base 10, then you're going to have to put it in like this. Log, I'm not going to write the 10 there. It's assumed to be 10 if I don't write it. So log 1594323 over log base 10 of 3. Okay? Anyways, you punch that in and you end up with an n of 13. Okay? So that means the sum of 13 gives you, what was it? Negative 797,161. Sum of 13 terms sums up to negative 797,161. Thanks for listening, guys. Bring your questions to class. See you then.